Now it's time to take a look at some of the Pic18 features, some of the standard things that we find on a PIC. The Pic18 has what's called a RISC architecture, reduced instruction set, that comes with some standard features such as on-chip programming, the code in the ROM, data RAM, data EEPROM, timers, an analog to digital converter, and a USART, which is the Universal Asynchronous Receive and Transmit function, and I/O ports. You can see from the diagram that although the size of the program ROM and data RAM, EEPROM, and I/O ports vary among the family members, they all have peripherals such as timers, analog and digital converters, and a USART. If we take a look at the larger scale, more detailed diagram of each of these, here we have the Pic18. We'll look at the 16. I flashed these up here a couple times already. Due to the importance of the peripherals, we have dedicated later an entire chapter to each of them. So we'll be getting into this in more detail later. The details of the RAM and the ROM memory and the I/O features of the Pic18 will be given in the next few chapters and videos. So you can see there the Pic18. You'll be seeing this diagram more as we progress, and the Pic16 identifying some of its features. In microcontrollers, the ROM is used to store programs, and for that reason it is called program or code ROM. Although the Pic18 has 2 megabytes of program code ROM space, not all family members come with that much ROM installed. The program ROM size can vary from 4K to 128K at the time of this writing, depending on the family member. The Pic18 program ROM is available in different memory types such as flash, OTP, and mask, all of which have different part numbers. A discussion of the various types of ROMs are given later. If you need to refresh your memory on these important memory technologies, we will do that at that time. Note that although different flavors of the Pic18 exist in terms of speed and the amount of on-chip RAM and ROM, they're all compatible with each other as far as the instructions are concerned. This means that if you write your program for one, it will run on any of them regardless of the chip number. Next, we'll take a look at the program Rom Type for the Pic18. Some of the PIC microcontrollers use an ultraviolet or UV EEPROM for on-chip program ROM. To these kinds of chips, for development requires access to a PROM burner, as well as a UV EEPROM eraser to erase the contents of the ROM. The window on the UV EEPROM chip allows the ultraviolet light to erase the ROM. The problem with the UV EEPROM is that it takes a long time. It takes up to 20 minutes to erase the chip before it can be programmed again. This has led Microchip to introduce a flash version of the PC family. At this time, flash is replacing the UV EEPROM altogether. Many Pic18 chips have on-chip program ROM in the form of flash memory. The flash version uses the letter F in the part number to indicate that the on-chip ROM is of the flash type. Pic18 F458 is an example of Pic18 with flash ROM. The flash version is ideal for fast development because flash memory can be erased in seconds compared to 20 minutes or more needed for UV or 20 minutes or more needed for UV EEPROM. For this reason, the Pic18F has been used in place of the UV EEPROM to eliminate waiting time needed to erase the chip, thereby speeding up the development time. To use the Pic18F to develop a microcontroller-based system requires a ROM burner that supports flash memory. However, a ROM eraser is not needed because flash is an EEPROM, electrically erasable PROM. Notice that in flash memory you must erase the entire contents of ROM in order to program it again. This erasing of flash is done by the ROM programmer itself, and so a separate eraser is not needed. We can also program the Pic18F via the Pic-Kit2 from Microchip using the USB port of a PC, and that's exactly what we will be using in the course. Okay, so that Pic-Kit you'll see later as we progress through these slides. So I actually have a picture of it, so you'll be getting lots of time using the Pic-Kit2. The OTP one-time programmable versions of PIC are also available from Microchip. The Pic18 432 chip uses one-time programmable to program its ROM. If you contrast that with the Pic18 432 and the Pic18F 252, you'll see that the letter C indicates the OTP PROM, while the letter F is for flash. The flash version is typically used for product development. When a product is designed and absolutely finalized, the OTP version of the PIC is used for mass production because it's cheaper than flash in terms of the price per unit. The problem with the OTP, though, is that you cannot reprogram it if you want to modify the program. So you got to make sure that you absolutely are done with development before you select OTP. The other version, the mask version, Microchip Corporation provides a service in which you can send your program and they will burn the program into the PIC chip during the fabrication process of the chip. This chip is commonly referred to as masked PIC, which is one of the stages of the IC fabrication. Masked PIC is the cheapest of all types if the unit numbers are high enough. This is because there is a minimum order for the masked version of the PIC type microcontrollers. While PROM is used to store program code, the RAM space is for data storage. The Pic18 has a maximum of 4096 bytes, 4K, of data RAM space. Not all of the family members come with that much RAM. The data RAM size for the Pic18 varies from 256 bytes up to 4096 bytes. As we will see, the data RAM space has two components, something called the general purpose RAM, the GPR, and the special function registers, SFR. So these are two acronyms that you'll be seeing over and over again as we proceed with the Pic18. Because the SFRs are fixed and every microcontroller must have them, it is the GPR's size that varies from chip to chip. For this reason, the Microchip website gives only the general purpose RAM size. The RAM GPR space is used for read-write scratchpad and data manipulation and is divided into banks of 256 bytes each. We'll see that later on. The GPR size given for the Pic18 is always a multiple of 256 bytes. In some of the Pic18 family members, we will also see a small amount of EEPROM to store critical data that does not need to be changed very often. While every Pic18 must have some data RAM for scratchpad, the EEPROM is optional. So not all versions of the Pic18 come with EEPROM. EEPROM is used mainly for storage of critical data. The Pic18 can have from 16 to 72 dedicated I/O pins. The number of I/O pins depends on the number of pins in the package itself. The number of pins for the Pic18 package goes from 18 to 80 and we've mentioned that before. In the case of the 18-pin Pic18F1220, we have 16 pins for I/O, while in the case of the 80-pin Pic18F8722, we can use up to 72 pins for I/O. We'll take a look at this when we get to the programming function. All the members of the Pic18 family come with an analog to digital converter, timers, and the USART, Universal Synchronous Asynchronous Receiver Transmitter, as standard peripherals. The ADC is 10-bit, and the number of ADC channels in each PIC varies from 5 to 16 depending on the number of pins in the package. The Pic18 can have up to 4 timers besides the watchdog timer. We'll examine the timers later. The USART peripheral allows us to connect the Pic18 base system to serial ports such as a COM port of the PC, and we'll see that again later. Many of the Pic18 family members come with the PC and CAN bus as well. Now, that PicKit2, that's what the card itself, the Pic18 card looks like, the trainer, and the PicKit2, that little device that you use to talk to the card itself. We'll discuss the design of the Pic18 F48058 trainer extensively. This trainer is programmed using the PicKit2. Okay, so we're going to see that as we progress through the course. As I mentioned earlier, using the website, there's a lot more up-to-date information, and we'll be using that website and tapping into the other useful information that's available. So that's the overview then of the Pic18 family. We can see here that for other microcontrollers that we will talk about but we won't particularly use, there are websites also available that you can find more information on. I actually have the 8051, but I chose the Pic18 because of the use of the PicKit2.